an example of using stoichiometry with ideal gas law, or stoichiometry with gases in it, which allows us to use the ideal gas law. Again, we have to start with a balanced chemical equation. And so we're going to use the same equation that was in the previous problem, which is zinc is reacting with HCl to produce zinc chloride and hydrogen gas. So hydrogen gas is the only gaseous product here. The other one is aqueous. We did this exact reaction in our chemical reactions lab a long time ago, and the zinc was solid. And then to balance this reaction, we required a 2 coefficient right there. But in this problem now, they give us that we are reacting 14.5 grams of zinc with lots and lots of HCl, so the limiting reactant is the zinc, and we are going to produce these two products. The question is, how many liters, not how many moles, not how many grams, how many liters of hydrogen gas are we going to produce? That's a different question than the ones that we've answered in the past. In the past, we were able to do stoichiometry to figure out how many grams or how many moles of hydrogen gas. The problem is gases are hard to measure in grams. So we could trap it in a container and measure the volume much easier than we could get the mass of it. So this is what we were trying to find. I'm going to gather my information from the problem, which tells me that the temperature this whole thing is going to happen at is 20 degrees Celsius. Again, I don't like Celsius. We need to convert right away to Kelvin, and so we get 293 Kelvin. The pressure is given, that's 760 millimeters of mercury. Again, with the constant that we've been using, we want to have ATMs for our pressure units. And so it's 760 millimeters of mercury is 1 atmosphere of pressure. So the millimeters of mercury cancel, and you get 1.00 ATM, keeping the same number of significant figures. I always know the constant. The constant is for all ideal gases, 0.0821 ATM times liters over moles times Kelvin. And then I have, that's it. I don't have the number of moles, and I don't have the volume. So can I use the ideal gas law with this given information? No, I can't, because I don't have enough variables to plug into my PV equals nRT. I have 2 unknowns, and so that won't work to solve. However, I have this mass of zinc, and so we did stoichiometry a while ago, and with that mass of zinc, I am able to figure out the moles of H2O that should be produced. Moles of H2O is hard to measure, but it's easy to calculate. So I have 14.5 grams of zinc. I don't want to know how many grams of zinc I have. I want to figure out how many moles of hydrogen. Before I can get moles of hydrogen, though, I have to convert my grams of zinc to moles of zinc. So that's 65.39 grams of zinc in every 1 mole of zinc. So my grams of zinc cancel. So now I'm in moles of zinc. I don't want moles of zinc, though. I want moles of H2O, or H2. So for every 1 mole of zinc, according to my chemical reaction, coefficient in front here is 1, there is 1 mole of hydrogen gas produced. Moles of zinc cancel, and you can get moles of hydrogen gas produced. When I calculate then, 14.5 times 1 times 1, please do not put that in your calculator, divided by 65.39, I get 0.221746 moles of hydrogen gas was produced. That is the amount of hydrogen gas I produced. Very difficult to measure that, though. So the way that we would measure it is in a volume. But now I have another variable for my ideal gas law, that 0.221746 moles. So now I do only have one unknown variable in my ideal gas law, and that one unknown variable is the volume. So when I say PV equals nRT, and I divide both sides by the pressure to get my volume by itself, because pressure divided by pressure would be 1, volume is going to be equal to those number of moles, 0.221746, times my constant, 0.0821, times my temperature, 293, divided by my pressure, 1 atm. I calculate, and I get a volume of 5.334. And the units for volume are liters. Then I go back to my problem, and I have 3 sig figs for my mass. I only have 2 for this temperature, but when I add 273, I get 3. And then I have 3 for my pressure, so my answer can have 5.33 liters H2. Put a box around that answer, and you're good to go.